In this video, I want to talk a little bit about the initiation of translation, and I'm going to be talking about it specifically involving prokaryotes. And then I'm going to talk about how eukaryotes are a little bit different towards the end of the video. So we want to start off translation, and translation is taking mRNA and turning it into proteins. Now, what we need ribosomes to come over to the mRNA and begin to actually translate it. So we know that translation is supposed to start at AUGs, but how do we know which AUG to start at? In prokaryotes, they have this little sequence called the Shine-Delgarno sequence. Delgarno sequence. And it consists of a few purine residues. And shortly after that, the first AUG that follows the Shine-Delgarno sequence is where translation initiates. So it's at that first AUG that follows the Shine-Delgarno sequence, that's where we want the ribosomes to go. So what's going to go over to that AUG first? Well, there's this 30S ribosomal subunit, and that's going to be the small ribosomal subunit. And it is going to go to that AUG along with a few other things to form what's called the 30S initiation complex. So that 30S initiation complex consists of 4 different things. Those 4 different things are, of course, the 30S subunit itself, the 30S ribosomal subunit, so that is the small ribosomal subunit. So that it's going to bring in and get ready to incorporate the first amino acid. So that first amino acid, or that first thing that's going to incorporate, is the formulated methyl tRNA that's specific for formulated methionine. So that's the F-met tRNA that is specific for F-met. That's going to come in. Also, they're also going to be joining the mRNA, right? That's where they're going in the first place. They're going to this mRNA. Now, the fourth and final thing are these things called initiation factors. These initiation factors come along with the 30S ribosomal subunit. So they all come on over to this first AUG that follows the Shine-Delgarno sequence, and they're going to come over and form the pre-initiation complex. So here we have the formulated methionine, so that's going to come over. So is the 30S ribosomal subunit with its initiation factors, and they're all going to come over to the mRNA. So now the first amino acid, of course, that's going to be incorporated is the formulated methionine. Now, once this initiation complex forms, the formation of this complex recruits the 50S subunit, which is the large ribosomal subunit. So then this thing will now go over and join this complex, and that forms what is called the 70S ribosome. Now, you might be thinking 30S plus 50S, that doesn't equal 30 plus 50 doesn't equal 70, it equals 80. And you're right, but the S stands for Svedberg units, which are units of the rate of sedimentation, and those units are actually not additive. So in this case, just trust that 30 plus 50 equals 70 for the prokaryotic ribosome. So now, once this happens, there is a GTP on one of these initiation factors. So if we have initiation factor here, there is a GTP that is on these initiation factors. So this GTP is going to be hydrolyzed to a GDP and an inorganic phosphate, and then translation begins. That's pretty much it. How is this different in eukaryotes? There are a few key differences. AUG is the start codon, just like it is in prokaryotes, but eukaryotes, they need a specific tRNA called tRNAi, which and the I stands for initiator. So this tRNA is the initiator tRNA. It's comparable to the tRNA F-met, which is the initiator tRNA in prokaryotes. The second thing is that there is no Shine-Dalgarno sequence. The first AUG following the 5' cap is where translation begins. So it's not the first AUG after a particular sequence, it's just the first AUG that would come after the 5' end of an mRNA strand in a eukaryote is where translation would begin. There are many initiation factors, and they're called EIFs, and the E just stands for eukaryotic. The last thing is that the small ribosomal subunit in eukaryotes is 40S. Let me actually keep that in white. It is 40S, and the large one is 60S. And you might think that that'll add up to 100S, and that's not the case. 40S plus 60S will equal an 80S complete ribosome. So that's the difference in eukaryotes. Otherwise, it's pretty much the same. You form the initiation complex with the small ribosomal subunit, the initial tRNA, the mRNA, and some initiation factors, and then that'll recruit the larger ribosomal subunit, and once that's there, you hydrolyze a GTP, and then translation begins. Hope that video was helpful. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com, and see the description below for more details. Thank you for watching.